Hello and welcome to Density Demonstrations. I am your host, Mr. Roth, and we are going to be doing some density demonstrations. So first things first, we're going to just kind of do a little quick talk about what is density, okay? So density is the amount of stuff that is packed in a certain amount of space. The formula for density, as you may or may not know, is density equals mass divided by volume. So it is a comparison between mass and volume. Okay, the more mass there is in a space, the more dense it is. So we are going to be comparing some densities of some things today. Now, here I have a bucket of water. It's not a bucket, I guess, a bin, but whatever. So a bin of water, and so if you did not know, the density of water, pure water, excuse me, is 1.00 grams per milliliter. Okay. So we are going to be making some guesses and some predictions on what these different things are going to do in water. So first one is an easy one. I have a ping pong ball. Okay, so I'm going to give you a quick pause, and what I want you to do is make a prediction on what you think the ping pong ball is going to do. Do you think it will sink in the water, or do you think it will float? All right, so we're going to put it in there. Look at that, it floated. You guys probably all knew that because we were starting with an easy one, but that's okay. Next one we're going to do is a little metal ball bearing. Okay, I know it's kind of tricky to see, but it is a metal ball bearing. So again, pause so you can make your prediction. All right, so we're going to put it in there and we're going to see what happens. Look at that, sank like a rock. Which you guys probably predicted, but maybe not, but that's okay. All right, next we are going to do a golf ball. Okay, so another pause, make your prediction. Okay, see what happens. Ooh, that sunk too. Not quite as fast as the ball bearing though, right? So what do you think that means? All right, next is a tennis ball. We're going to put that tennis ball in the water. We're going to see what happens. Okay, pause for prediction. All right, we're going to put it in there, see what happens. That floated. Hooray. Okay, next, we're going to try something here. We got 2 cans of Coke. Okay, one is regular Coke, one is Diet Coke. Okay, what do you think is going to happen? First, what do you think is going to happen with the regular Coke? Now, what do you think is going to happen with the Diet Coke? Now, we're going to put it in and see what happens. Look at that. So, the Diet Coke floated. The regular Coke did not float. Why do you think that is? So, the reason why the Diet Coke floats and the regular Coke sinks is because the Diet Coke has artificial sweetener in it, whereas the regular Coke has regular sugar. Okay? So sugar is more dense than the artificial sweetener. So that's why, even though they are the same size, same shape, same volume, the actual mass of the regular Coke is greater than the Diet Coke, because the regular Coke uses regular sugar, which is more dense than the Diet Coke. Okay? All right, so last thing that we're going to do for floating is a bowling ball. Okay? So, quick pause. What do you think is going to happen when I put the bowling ball in the water? Will it sink or will it float? Okay, let's try. Holy cow, this bowling ball is floating. Now, some of you may have guessed that. Some of you may be like, how in the heck is a bowling ball floating? It's way heavier than all that other stuff, right? So, like, for example, we have the metal ball, right? The metal ball sunk like a rock, but it's not nearly as heavy as the bowling ball. So how does that work? Well, The reason that the bowling ball floats is, remember, density is not just how heavy something is. Density is how much stuff is packed in a certain space. So even though the ball is heavier than all of this other stuff, it's still going to float because the ratio of mass versus volume is still less than the stuff that sank. Okay, so the density is not just based on mass, right? Density is based on how much mass versus volume there is. So just because something is really heavy doesn't mean it's not going to sink. Okay? All right, last thing we're going to do is this Cartesian diver. I think I'm just going to move this over a little bit so I have a little bit more room. So this is what's called a Cartesian diver. Now, maybe I'm going to go up here so you can see it a little bit better. Okay, so as you can see, it has that little pipette inside of it. Okay, now what I'm going to do is I'm going to make that pipette sink inside the Cartesian diver. Just like that. Okay, so as you can see, what I'm doing is I am squeezing the Cartesian diver. Now, what happens when I do that, and actually I'm going to do a quick pause so you can answer that. Why do you think that makes the pipette sink when I squeeze? So what is actually happening is when I squeeze, okay, as you can see inside that pipette, there's that bubble right there, okay? As I squeeze, that bubble gets smaller, right? So what's actually happening is when I squeeze that, I am forcing the water that's in the Cartesian diver up higher into the pipette. And that's compressing the gas inside that pipette. Now when that gas gets compressed and more water gets into the pipette, the density of the pipette increases so that the density of the pipette turns into a greater density than the water, and so therefore it sinks. Okay, that is all the demonstrations we have for today. Thanks for watching. Have a good one.